Welcome back to our TxePrep video, and in this video we're going to talk about the USACO 2020 February Bronze Contest, problem number 3, Swapity Swap. So let's just start reading the problem. Farmer John's N cows, N being between 1 and 100, are standing in a line. The ith cow from the left has a label I for each 1 is less than or equal to I, which is less than or equal to N. Farmer John has come up with a new morning exercise routine for the cows. He tells them to repeat the following two-step process exactly K being between 1 and 10 to the 9th times. So step 1 is that the sequence of cows currently in positions between A1 and A2 from the left reverse their order, and then the sequence of cows currently in positions B1 through B2 from the left reverse their order. After the cows have repeated this process exactly K times, please output the label of the ith cow from the left for each 1 is less than or equal to I, which is less than or equal to N. And for our input format, we're given that the first line contains N and K, N being the number of cows and K being the number of times that the process is supposed to be repeated, and the second line contains A1 and A2, while the third line contains B1 and B2. On the ith line of input, print the label of the ith cow from the left at the end of each exercise routine. So let's just try kicking in these inputs and then testing them. So we notice that we have 7 cows, so I'm going to create just a line of 7 cows. And then we also notice that we want to flip between cows 2 and 5 and cows 3 and 7 2 times, right? So what we're going to do, cows between 2 and 5, we're going to reverse their order, so now it'll become 1, 5, 4, 3, 2, 6, 7, right? And then the next one is between 3 and 7, and so now we're going to have 1, 5, and then the cows between 4 to 7 flip their order. So now 7, 6, 2, 3, 4. And we're asked to repeat this process 2 times. So now we're going to flip the positions between 2 and 5 again. So now this will be 1, 2, 6, 7, 5, 3, 4. And now we're going to flip the positions between 3 and 7 again. So now it'll become 1, 2, 4, 3, 5, 7, 6. And as we see over here, 1, 2, 3, 4, 5, 7, 6, which is exactly what we want to do. So now we're programming this. So I've set up the input file and the output file, and this is what the output's supposed to be, but I'll clear it for now. And this is what our input is supposed to be. And then here's our main. So what we're going to do is we're going to include fstream so that we can do our fn and fout. And then using namespace standard. And then our if stream, which is coming from swap.in, and then our offstream, which is coming from if stream fin, we need to give it a name, and offstream fout, we need to give it a name, and swap.out. So now what we have are our 2 integers, int n and int k. So I'm going to initialize them or declare them. And then I'm going to start my program. And obviously the first thing I'm going to do is read in n and then read in k, right? And then what we're going to do after that is create a of 1 and b of a of 1, a of 2, b of 1, and b of 2, and then read them in. So I'm going to create int a1, b1, or sorry, a1, a2, b1, b2. And then I'm going to read them in. Okay, so now that I have that set up, what I have to do now is actually simulate this process. So the first thing I'm going to do is initialize an array. So int array, which is just going to be an array with the size of n, right? And it's going to have int I is equal to 0. So what it's going to have is just the values 1, 2, 3, 4, and so on. Right, so we're just going to say array of I is equal to I plus 1, right? Because our I starts from 0 and we want our index at 0 to be 1. And so on for the rest of the array. So now let's actually start with the program. Now what we're going to do is actually implement the process that we're asked to implement, right? So if we look over here, suppose we want to flip between positions 2 and 5. So what we're going to do is we're going to do position number 5 minus position number 2, so 5 minus 2, which is 3, and then divide that by 2 and round up. So for example, 5 minus 2 in this case is going to be 3, and then we're going to divide that by 2, which is 1.5, and we're going to we're gonna round up, right? And that's the number of times that a flip will essentially be carried out, because what we're gonna do is change 5 with 2 and change 4 with 3. And as you notice that there are only going to be two times that the computer has to do something. But for example, if we want to do between positions 3 and position 7, we notice that we have 7 over here and we have 3 over here. So 7 minus 3 is 4, and if we divide it by 2, then we get 2 as our 7 minus 3 divided by 2 is simply just going to be 2, meaning that we're going to flip 6 and 4, and we're going to flip 7 and 3, and obviously 5 stays where it was because it's simply just in the middle. So that's what we're going to implement. So if we go over here, now I'm going to create the variable j. I'm going to initialize it to 0, and I'm going to say while j is less than k, meaning I'm just going to iterate through this process k times. So while j is less than k, what I'm going to do for int I is equal to 0, I is less than, and we want to remember how many times we want to do it, which is simply just the a2 minus a, I'm going to put this in parentheses, a2 minus a1 plus 1 divided by 2. And the plus 1 is just there to help us round, and then I plus plus. And in there, we're going to swap them. What we're going to do is use swap, and now what we're going to do is put in the array. So array of I plus a1 minus 1, right? That's basically just saying the value that we want to swap. So for example, if we want to do 2, what we will do is do 2 and 5. So in this case, it would be I plus a1 minus 1. And we're also going to swap it with the opposite, which would be 5 in this case, position number 5. And that would be array at a2 minus 1, I minus 1, right? And then what we'll do is create another for loop to simulate step number 2. And it's basically a really similar process. So I is less than b2 minus b1 plus 1 divided by 2, and then we're going to do I plus plus. Right, and in here, oh, I should have done plus 1, okay. And then in here, we're going to do the same similar process, swap array of I plus b1 minus 1, and array of b2 minus I minus 1. And the minus 1 is there just to offset for the fact that at an array of 0, our position is going to be 1. Our integer is going to be 1, not exactly 0, because it's just a mismatch by 1. That's basically what the minus 1 is there for. So now that we have that, we can increment j, and it'll take place. And that should be what our final answer is. And what we're going to do now is simply just print out the array. So for int I is equal to 0, I is less than n, I plus plus, we're just going to print out the array. And then end line. And let's just see if this ends up working. Okay, so I just submitted that solution to see if it works, and let's just see if it works. And oh no, we're starting to get a bunch of times because it's taking too long. And the reason for that is because k can go up to 10 to the power of 9, which is a billion. And that is obviously too slow if we're just going to put in a for loop. What we can notice, however, is that eventually, what's going to happen is that the swapping is going to end up repeating. So what I mean by that is eventually if we do something like this enough amount of times, we're going to get back to the point where this is going to be 1, 5, 4, 3, 2, 6, or 3, 2, 6, 7, and it's even going to get back to the point of the original array. So what we want to do now is check how many times it's going to take for it to reach an original array. So I'm going to create another array, so we can do that, called int orig, and call it n. And what I'm going to do is just copy the original array into this new array that we're using. Okay, so now that I have that done, so now what I'm going to do is I'm going to check at the end of each iteration of completing these two steps, I'm going to check if the original array is equal to the modified array that with all the swaps. So I'm going to say if array equal, and this is obviously a function that I haven't created yet, but I will create that, and I'm going to pass in my original array, which is just going to be, I'm just going to say orig, then, orig, array, and then, yeah, so now I'm going to create a function for that. So I'm going to say int array equal, and sorry, it would be a boolean to check because it's a true or false condition, right? So I'm going to say int original array, and then our int just regular array that we had from before. So now let's just try creating the function. So if we want to create the function, what we're going to do is I'm just going to start by saying that our bool answer is equal to true, and if a condition comes up such that it's not true, we're just going to change it to false and then return that false. So now I'm going to iterate through the entire array. So for int I is equal to 0, I is less than n, I plus plus, if the original at I does not equal to the array that we have at I, then our answer will be equal to false, and we're gonna have false as our answer, and then we're gonna return the answer. So if it's true, then we will continue on this path. And for this path, what we're gonna do is we're going to simulate the exact same process, but instead of doing it the entire k amount of times, we're gonna use a remainder. So for example, what I'm gonna do here is I'm gonna say that int x is equal to j, right? And what I'm going to do after that, what int x equal to j meaning is that it repeats after exactly x times. So now what I'm going to do after that is I'm going to basically copy and paste these for loops over here, because they're exactly the process that we want to simulate, right? But instead of, I have to indent these. What I'm going to do now is create a for loop. And I'm going to say for int I is equal to 0, I is less than k, remainder x. And this is basically our principle of having a remainder to make sure that we don't exceed our time limit, because k is going to be 10 to the power of 9, right? So now we can do I plus plus. Actually, let's make it a different variable since our variables over here are different. So I'm going to call it something like L. And then I'm going to put everything over here into that for loop. And we have to obviously tab everything in, make sure indentation looks right. And now we can just basically do this and still get the exact same answer. But we need to make sure that we break out of the while loop, otherwise we're gonna iterate the full k times. So once we break, we're done with it, and then we can try running it. So let's just try running it. So we do get our answer of 1, 2, 4, 3, 5, 7, 6. Which is the right answer. So 1, 2, 4, 3, 5, 7, 6. Yep, that's the right answer. So now I'm going to try submitting this over here. So now as you can see, I'm about to submit it. And let's see what our verdict says. Okay, so it seems like, okay, yep. So it seems like it's going to work. Everything is a perfect green that we want it to be. And everything basically runs in 1 millisecond except for the last one. But that's completely fine. We did this problem very well. I would say it's a pretty good solution. Alright, that's it for this video. See you guys next time.